So it's Wednesday right now, Wednesday afternoon. It's 8 p.m. in the afternoon and it's still this bright. So there's a patch of no clouds above us. As far as I've seen on the forecast, there are clouds all around us, but they are supposed to stay away. And I hope so, because tonight I'm gonna take an image of a very cool nebula. Hello Astro Addicts, my name is Tim and welcome back to Astro Addict. Tonight I not only have some upgrades for the camera outside at the telescope, I also have some upgrades for the camera in here. And what I have is a little change camera-wise. So I hope that these upgrades, the microphone and now the DSLR instead of the small digital camera, will improve the production quality of these videos and in general will hopefully produce some higher quality images. What's gonna be the target for tonight, you might ask? For this question I've prepared a little something for you. Enjoy! Maybe you've heard of it, the Iris-Nebula in the constellation Cepheus. The official name NGC 7023. As far as I know, I've seen some pictures of it online. It's a reflection nebulae, blue color, surrounded by clouds of dark dust, which is blocking some of the reflection happening, which makes it a very eye-shaped nebula, so I hope that it will show up on these pictures pretty nice. While setting up, I wondered, I tried out what exposure time and ISO I should use, because I never shot this target before, I don't know. I ended up with 3.5 minutes, 210 seconds at ISO 800. I tried swapping it out to 3 minutes at 1600, but the difference exposure-wise wasn't very comforting, so I bumped it down to ISO 800 again and 3.5 minutes, so I won't have that much noise in the frame. The hot temperatures of the last days are gone. Thank God. Now the sensor is at 25 degrees Celsius. Could be colder, but way better than 33 degrees Celsius you saw in the Pelican Nebula. Awful lot of noise. So I really hope that this image will deliver tonight. So I hope that the DSLR has the right focus now. I might be able to focus a 7-14mm scope, but focusing a DSLR camera with the normal stock lens, kinda impossible for me. So, a new perspective, I hope you like it. I try to do something different every day. PhD is running pretty good right now after the pole drift alignment. And the only thing I can do now is wait. Because this hobby consists of setting up everything, the equipment, the entire rig, and then mostly struggling with clouds or technical problems. But if you don't have anything of that in the night, the only thing you can do is wait. So here we are back in APT, Astrophotography tool. I just want to talk a little bit about this program and just to fuel your nightmares a little bit. Here is the webcam with some spooky lightning. I hope this works. So let's try and make this lightning a little less spooky. I hope my face is not overexposed right now. Just get this over here. So here we are in APT, probably the best software to capture your deep sky images with your DSLR and your CCD. I'm not making advertisements here, I just love this. I just love this program so much, I want to talk about it. So I connect my DSLR over, via the USB cable. I just hit connect and it connects it for me. And then almost everything is set for your night of deep sky imaging. Over here you can edit your plans, which means you can set the exposure, ISO, pause, count, quality and much more. And as soon as you hit start, it's gonna control the camera and capture your image, your desired image. But not only that, there are so many features which I love about this program. For example, something I could not control in the camera, the mirror lockup, also known as the anti-vibration pause in APT. So it basically, before the light enters the sensor, the mirror and the shutter is in the way, and the mirror flip of any DSLR is gonna produce camera shake, which can blur your image. So it's not gonna set the exposure right when the mirror flips. It waits 3 seconds in my case, because I told it to wait 3 seconds. And just to reduce the camera shake a little bit more. And if you have seen my last video, I talked a little bit about focusing with the Bahtinov mask. If you go in the Tools tab, there's the Bahtinov 8 window. You can click on this tab. And if you have your captured Bahtinov image here, you can use this tool to line up the crosshairs here. You press recalculate, and it will tell you the distance or how good your focusing using the Bahtinov mask is. Even if I think, looking with my eyes, that the focus is good, that the spike is aligned between the X, even this program can tell a little difference, and I can get it way sharper. There are lots of tools here, I only need a few of them. I'm also using the framing masks and sometimes the magnifier to control the sharpness in the image. And one thing I love about this program is the object calculator. I've heard about many websites online that do the same thing, but I found that this is the most responsive and exact method to calculate the object size. So I entered the focal length of my scope and entered the camera model, and now here is a list of almost most known deep sky objects. So now in my case I can enter, I hope I can see the 7023. I click on search, and here it is, the Iris-Nebula. I press OK, and here you can see, okay, it's a little bit smaller, but maybe let's stretch it a little bit. The outer darkness in the Iris-Nebula, I think it's pretty exact in the size. So this is a very handy tool of this program. So over here on the left you can see we are on exposure 9 of 50, 23 seconds in. This plan is gonna stop at 2:21 AM. It's telling me the laptop charge, the camera charge, how much space is left on the SD card of the camera, and the current PSG state 0.8, 0.4, which is apparently not the case, because this dither took everything out of this statement here, it will disappear soon. And the histogram is over here, the RGB and the luminance layer. We can show this in a logarithmic view, stretch the image to which helps in framing and focusing with the button of mask. The log down here is gonna tell you everything that happened, even the temperature if you shoot it in raw images, the temperature of the sensor, which is pretty cool. Over here you can connect all your gear. I can't connect my scope, I don't have a focuser, I don't have a focus wheel or a rotator, so I can't use anything of these. In the image tab over here you can preview the images you've shot and make some effects on it. For example, to flip it, to stack it in live view, which is pretty cool, and make some basic adjustments for the preview, not for the final image. And the tab that I also open is the graphs tab over here, and I like to switch to the guide tab over here. So everything below this line here is pretty good, below 1 arcsecond in accuracy. And these large peaks here are the dithering commands, so that's no problem because the camera was not capturing at that point. So yeah, I think that's the big I don't know the right English term. That's the basics you need to know about APT. A small little update. I think you can guess what happened. Yes. So in this state APT wouldn't stop dithering, it waited minutes and minutes for the dithering to finish. And obviously in this state PhD is not going to tell that the dithering is done. And bad by me, I set the dithering timer to 3 minutes, and it wouldn't let me correct it down to 20 seconds because it was already running. So I restarted the plan, set the dithering timer to 20 seconds now, and hope that it will stop dithering, or at least abort the dithering. I don't think that it's doing any much good nonetheless. And if this bad graph continues, I really don't know what to do. The Iris-Nebula isn't even close to the meridian, but I still think that the distance to Polaris to the meridian is the problem here, because the distance is very small. I just hope maybe after midnight I can flip the scope and this graph will look normal again. Just one thing I forgot to mention. I of course want to make these videos as informative as I can. So in my camera I don't just have the camera attached to the scope, I have a light pollution filter from Astronomic, the CLS light pollution filter. The CLS stands for City Light Suppression. So since I am in the bottle 5 zone, in the red zone on the light pollution chart, I really need this. I'm in the middle of the city and the background would just look abnormal red in long exposures, so it's good that I have that thing. I also installed a battery grip and bought an extra battery pack, so this setup can get me through an entire night's worth of imaging, and I don't have to worry about swapping the battery packs of the camera in and out while the camera is imaging. This process would end up in some shaky frames. And the rest for the night, I will probably show you the meridian flip, and then let's see if the Iris-Nebula was worth the shot.